Automated documentation generation for Java DevOps pipelines with GenAI. Welcome, software engineers and IT enthusiasts. Have you ever felt the pain of outdated documentation? That crucial README file that's 2 versions behind, or the pipeline documentation that hasn't been touched since the initial setup? It's a common scenario, and it's a productivity killer. Manual documentation is tedious, time-consuming, and almost guaranteed to fall out of sync with your rapidly evolving codebase. But what if there was a way to automate this process, ensuring your documentation is always accurate, always up to date, and generated as an integral part of your development pipeline? Today, we're diving into exactly that, leveraging the power of generative AI, like OpenAI's GPT models or OCI AI, to automatically generate and update documentation for Java DevOps pipelines. Imagine a world where your READMEs, your internal pipeline guides, and even your API documentation are intelligently created from your code and configuration files, all without a single manual edit. This isn't science fiction, it's a powerful integration we can achieve right now. We'll explore a practical example, walk through the code, and see how this transformative technology can streamline your DevOps processes. In the dynamic world of DevOps, speed and agility are paramount. We push code, we deploy, we iterate, often multiple times a day. But documentation often gets left behind. Developers, rightly focused on shipping features and fixing bugs, view documentation as an overhead, a necessary evil rather than an integrated part of the development lifecycle. This leads to a growing gap between what the code does and what the documentation says. When new team members join, or when an issue arises, outdated documentation becomes a major bottleneck, hindering understanding and slowing down problem resolution. This paradox of rapid development versus stagnant documentation creates technical debt, confusion, and frustration. It's a problem that traditional static documentation tools struggle to solve because they still rely on human input and upkeep. We need a solution that is as agile as our development process, a solution that can understand the context of our code and infrastructure, and adapt to changes instantly. This is where generative AI steps in, offering a truly innovative approach to tackling this persistent challenge. Generative AI, with its ability to understand context, generate human-like text, and even comprehend code structures, is uniquely positioned to revolutionize how we handle documentation. Instead of manually writing or updating markdown files, we can feed our AI models snippets of source code, configuration files, and pipeline scripts. The AI can then interpret these inputs, identify key functionalities, parameters, and dependencies, and translate them into clear, concise, and comprehensive documentation. This isn't just about simple summarization, it's about intelligent synthesis. GenAI can analyze complex logic, identify the purpose of a service or a pipeline stage, and generate explanatory text that is coherent and technically accurate. It transforms the burdensome task of documentation into an automated, efficient process that keeps pace with development. By embedding this capability directly into our CI/CD pipelines, we ensure that documentation updates become an automatic outcome of every successful build or deployment, rather than an afterthought. To demonstrate this in action, we've put together a project called Doka Genius, Java DevOps AI Docs. This isn't a massive enterprise application, but a focused example designed to showcase the integration of GenAI into a Java DevOps workflow. At its core, it's a simple Spring Boot application, typical of many modern Java microservices. You'll find standard Java code in src/main/java, Maven configurations in pom.xml, and application properties in src/main/resources. But the real stars of this demo are in the scripts/directory. Here, we house our Python scripts for GenAI interaction and a shell script that simulates a CI/CD pipeline. The docs/directory is where all the magic happens. it's where our AI-generated documentation will land. This setup provides a clear, manageable environment to explore how code and configurations can be transformed into living documentation. The orchestrator of our automated process is the script/run_pipeline.sh bash script. This isn't a full-blown Jenkins or GitLab pipeline, but a highly effective simulation that demonstrates the core stages of a CI/CD workflow. It begins by building our Java application using Maven, executing mvn clean install to compile the code and package it. Next, it moves to a run test stage, which for this demo is a simple placeholder, but in a real pipeline, it would trigger comprehensive unit and integration tests to ensure code quality. The pivotal moment comes with the Generate Automated Documentation with GenAI stage. This is where our Python script is invoked, specifically designed to interact with the generative AI model. Finally, the pipeline concludes with a Deploy Application stage, another simulation, representing the deployment of our built and tested application to an environment. The beauty of this script is its simplicity and how it clearly showcases the automated documentation step right in the middle of a typical CI/CD flow. Now, let's peek under the hood at the brain of our documentation system, the script/generate_docs.py Python script. This script is responsible for the crucial task of gathering context from various parts of our project. It programmatically reads key files, such as our productservice.java file, which contains the business logic for managing products. It also ingests the pom.xml Maven configuration, understanding the project's dependencies and build structure. Furthermore, it reads our application.properties to grasp configuration details, and even parses the run_pipeline.sh script itself to understand the DevOps pipeline's flow. By collecting all these pieces of information, generate_docs.py builds a comprehensive understanding of the project's components and their interrelationships. This holistic context is absolutely vital for the GenAI model to produce truly accurate and relevant documentation, ensuring nothing important is missed. The quality of generated documentation hinges on effective, prompt engineering. Our generate_docs.py script doesn't just dump raw code into the AI. Instead, it carefully crafts a sophisticated prompt. It begins by establishing a system role, telling the AI to act as a highly experienced technical writer and software architect. This sets the tone and expectation for the AI's response. Then, it injects the collected file contents, the Java code, Maven XML, pipeline script, and application properties, into the user prompt. Crucially, it provides explicit instructions on what aspects to focus on: pipeline overview, stages, tools, the documentation step itself, benefits, and usage. This detailed guidance ensures the AI understands precisely what kind of documentation is needed, preventing generic or irrelevant output and guiding it to synthesize coherent, targeted explanations in Markdown format. With the prompt meticulously engineered, the generate_docs.py script initiates the interaction with the generative AI model. It uses the OpenAI Python library, specifically leveraging the client.chat.completions.create method. This method allows us to send our structured prompt, containing both the system message, defining the AI's persona, and the user message, containing the code context and instructions, to a powerful model like GPT-4 Turbo. The script handles the API call, ensuring that the necessary API key is loaded securely from an environment variable. Upon receiving the response from the AI, it extracts the generated content, which is typically a Markdown formatted string. Error handling is also built in, catching potential API errors or unexpected issues, ensuring robustness in the documentation generation process. This seamless interaction between our local script and the cloud-based AI service is what makes the magic happen. Once the GenAI model returns its crafted documentation, the generate_docs.py script takes that generated text and saves it directly into our docs/directory. For our demo, this results